Hello, in this video I'm going to help you learn how to analyze the motion of an object on an XvsT graph. If you notice, this graph has multiple slopes for each segment. Okay, so that means the object is going to be speeding up, slowing down, changing direction, etc. Okay? The first thing that I did whenever I look at some kind of graph like this is label my x and y axis, make my life easy, okay? Then I drew in my triangles and labeled the points at which the slope changes, okay? So the reason why I label my triangles, because the base of the triangles represents the time taken for each segment, and then the height of each triangle represents the displacement for the segment, meaning how far the object traveled from its starting position for that segment, okay? This will help me in the future when I'm looking at the displacement for each segment or the velocity, etc., okay? The next thing I'm going to do is label the slopes of each line. Now, on an XvsT graph, I know the slope represents the velocity of the object. So the first slope is positive, meaning the velocity is positive. The second segment has a negative slope, or a negative velocity. The third segment has no motion, meaning the velocity is 0. Okay, slope of a straight line is 0, or a flat line, I should say. The next slope is positive, so the velocity is positive, and the last one is also positive. Just because it's below the x-axis doesn't change the slope being positive or negative, okay? It's all about the direction that it's going in. Next, I'm going to find the displacements for each segment. So I'm going to find the height of each triangle. The first one goes from -12 to +20, so it is a +32 meters. Second segment goes from +20 to -20. Okay, it's a negative velocity, so therefore it is a negative displacement, -40 meters. We know if the velocity is 0, the displacement is also 0. The next segment is positive direction, and it goes from -20 to -8, so that's a +12 meters. And the last segment is also positive. It goes from -8 to +16, which is a +24 meters. Okay, now we have all of our displacements. We can draw out the motion of the object in one plane, meaning one dimension. Okay, I like to say if it's a positive velocity, meaning the direction, right, the direction of motion always is determined by the velocity. So if it's positive, it's going to the right. If it's negative, it's going to the left in one dimension, okay? If you would like to use up and down, that's fine, but I prefer to be horizontal because that's how I walk. So, +32 from my starting point is to the right for 32. Okay, I'm just going to eyeball it. It doesn't have to be drawn to scale, but it should be relative to the sizes for each displacement. From there, from this point here, I go left for 40. Then I come to a stop for 5 seconds, and then I move to the right for 12 meters. And then I move again 24. Okay, again, this is not drawn to scale, but it's relative to the values for each displacement, okay? Now let's start answering the questions. If you have me as a teacher, you have this worksheet in the first part of Chapter 1. It is XvsT practice number 1, okay? If you would like this worksheet, feel free to comment or send me an email, and I will be glad to send it on to you, okay? The object's starting position or starting location, we look right here, when t equals 0, it is at -12 meters. The object's velocity when t equals 8. Well, I find where 8 touches my segment. It is in segment 2. Notice, all of these are linear representations, meaning the velocities are constant. Okay? When that is constant, you know that the object's velocity doesn't change for that whole period of time. So